So far in chapter 4, we've been looking at probability. So empirical probability, theoretical probability, conditional probability. And so we know with probabilities, they should be between 0 and 1 inclusive. So whether that be in decimal notation, fraction notation, or it could be in percent notation. Again, if we take it out of percent notation, it should still fall between 0 and 1 inclusive. So our last section actually really doesn't have to do with probability, unless it's specifically asked, I guess, for the probability. But for most of these, we are going to look and find whole numbers. We want to know how many ways are there to do something. So we're going to start with our basic counting rule, which states that if we are asked to choose one item from each of two separate categories, where there are m items in the first category and n items in the second category, then the total number of available choices is, we have m times n. And this is sometimes called the basic counting rule for probabilities. Sometimes some books will say the counting principle. Now this was just for two choices, two categories. You could do 3, 4, 5, 9 categories. But so our basic counting principle. So what does this really look like? So we see it says a young man owns 4 dress shirts and 7 ties. How many different combinations of shirts and ties can he wear to work? So we have two categories, shirts and ties. We have 4 options for shirts and 7 options for ties. So 4 times 7 will give me 28 different combinations. So it says the basic counting rule can be extended when there are more than 2 categories by applying it repeatedly, as we see in the next problem. So 2 says a pizza place has pizzas in 4 different sizes with 12 different flavors for the crust and 10 different toppings. How many one topping pizzas can be ordered? So we have the 4 sizes, flavors of crust, and the toppings. So I have 4 different sizes, 12 different flavors, and 10 different toppings. So, my 4 times 12, will give me the 48 times the 10. You may be able to figure this out without your calculator, but we have 480 options, How many one topping pizzas can be ordered? 480, And if we let them choose, 2 toppings, 3 toppings, we'd have even more, but we're just sort of starting with the basics here. So, my basic counting principle, Look at the different categories, multiply the options together. So what if, arrangements with repetition? It says if we make our selections from a group of n choices, a total of n sub 1 times n sub 2 times n sub 3, ... or n to the r, different arrangements are possible. So example 1 says a person's social security number is made up of 9 digits. How many different social security numbers are possible? So I have 9 digits, So 2, 3, 4, 5, 6, 7, 8, 9, All the possible numbers. And if I think of my digits, my digits are 0 to 9 or 10 options, 10 options total. So if you think of a social security number, some of the digits can be repeated. So you'd have, 10 options for the first number, 10 options for the second, and the third, and the fourth, and sort of ... 10 options for each of our 9 digits. And so what we can actually say, instead of, 10 times 10, times 10 and so forth, we could say 10 to the 9th. And so 10 to the 9th, it's going to be lots of zeros. It's going to be 9 zeros. So 10 to the 9th, is going to be, so 1, 2, 3, 4, 5, 6, 7, 8, 9, And then I'll add my commas here. So a billion, 1 billion options.